Hello scientific audience, how are you all? So in this video, I'm going to talk about all the ray diagrams related to the convex lenses. So basically, I'm going to run through this lecture very fast, and this is very helpful video for all the students from grade 8 to grade 12. So very quick revision, you can use this video before the exams to learn all the ray diagrams and the important concepts related to them. Okay, so we know that in ray diagram, always the objects are kept on the left hand side of the lens. All right, and then we require at least two rays from the object which is going to follow the lens, and then on the basis of that we decide the nature of the image, where the image is formed, etc. Right, so the object over here is this one, that is the arrow, and we are going to only pull out all the rays from the arrowhead, right, and the image of the head will be formed simultaneously. So what I have done over here is, first ray I'm going to take it from the head of the object, and that is going to pass through the optical center, and those rays which pass through the optical center goes undeviated. And the second ray is parallel to the principal axis, and that ray after refraction will pass through the focus, right? So here I have kept the object between F and O. So what is going to happen? These two refracted rays, as you can see, that they are going far apart. So when the refracted rays on the other side of the lens, when they go far apart, a virtual image is formed. And in lenses, the virtual image is formed on the same side of the object. So you need to extend those two refracted rays backwards, and then finally you will see an enlarged virtual and direct image on the same side of the lens where the object is placed. So you can simply say that behind the object is the position of the image. It can be at 2f, it can be at f, it can be between f and 2f, depends upon how you draw the diagram. So please do not waste your time and understanding in where the image is. Just say behind the object and you would get the full marks, right? So let's move on to the second case. Here I am going to put the object at F. Now slightly what am I going to do is, I'm going to push the object behind, and finally I'm going to take the object at infinity. So the object is slightly going to go backwards, and finally the object at infinity. So here I'm again going to pull out one ray which is going to pass through the optical center and goes undeviated. The second ray is going to be the incident ray, which is parallel to the principal axis, and after refraction it is going to pass through focus. So that means I should be saying that this is our F2, right, and these two rays are perfectly parallel. Please understand, guys, that when you draw the diagram, the refracted rays has to be parallel. Now there is a little bit of a twist over here. We know that the parallel rays do not meet, but we make an assumption that these two parallel rays are going to meet at infinity, right? So if the refracted rays are meeting, always the image is real, and the real images are always inverted. So I should be saying that the image is real and inverted because the refracted rays which are parallel are going to meet at infinity. Now you would say, sir, this is absurd and I don't believe this. See, just imagine that you are standing on the top of the mountain, and at the bottom of the mountain there are two rail tracks, and when you look up at a very far away distance from the mountain, those two parallel rail tracks appears to be meeting at a very long distance. So in the same way, these two rays will definitely meet at a very long distance from the optical center, and in that case the image is real and inverted, right? We believe that these two refracted rays are meeting, that's why the image is real and inverted. Where are they meeting? At that point the image will be formed at infinity. Now the object is of course kept at F. Now please remember that when the object is at when the object is at infinity or the image is at infinity, under those circumstances you will use the word highly, whether magnified or highly enlarged or highly diminished. Highly word has to be only used when the object is at infinity or the image is at infinity. So here the image is going to be very, very big, and that's due to this reason. Suppose they meet over here, which is not possible, just to make you understand. Suppose these two refracted rays meet over here. That means this point is this much down with respect to principal axis. So this much big is going to be the image. But you know very well that these two rays are going to go at a very long distance. So that point where the refracted rays will meet is way below the principal axis. So huge, an enlarged and very highly magnified image will be formed. All right, let's go ahead. The object is kept between f and 2f. So that means the first ray, as usual, is going to pass through O, goes undeviated. The second ray is parallel to principal axis. After refraction, it goes through focus. And finally, enlarged image is formed beyond 2f. Correct. So this is a real and inverted image because the refracted rays, as you can see very well, they are meeting at this particular point. Now, since the rays are coming from the head, that's why the image of the head will be formed at bottom over here, and the tail of the object or feet of the object, whatever you may call, that will be formed on the principal axis. So now let's move on to the next case where the object is at 2f. Now the first ray is going to pass through O, goes undeviated. The second ray is incident ray, which is parallel to the principal axis. After refraction, it will pass through focus. And you can very well see that the image is formed of the same size as that of the object. And then that image is formed exactly at 2f. Real and inverted images are always formed opposite to the object where it is. That means if the object is on this side of the lens, then the image which is on this side of the lens has to be the real image. Whereas the virtual and direct images are formed on the same side as that of the object, right? So the same size as that of the object, height of the object is same as the height of the image. The image is formed at 2f. Now, this time we are going to place the object slightly behind 2f. So the first ray goes undeviated, passing through O. The second ray is going to intersect. The second incident ray is parallel to principal axis, passes through focus on the other side of the lens. Both the refracted rays are meeting. So real and inverted image for very small size is formed between f and 2f. In this case, we may want to call the image size as diminished, because the point where both the refracted rays are meeting is slightly below the principal axis. So the height of the image is small, so we will call only diminished image. The image is formed between f and 2f. Next case. Now here we are going to have the object at infinity, which means you are not supposed to show the object at all. Simply show two parallel rays which are parallel to the principal axis, and then after refraction they are going to meet at focus. Now guys, listen. Since the refracted rays are meeting at focus, so that means the image is formed at f. The image is real and inverted. That is due to the fact that both the refracted rays are meeting. Right. Now the object is at infinity. The word highly has to be used over here. Now why diminished? Just understand that had it been these two rays meeting over here, that means this point is way below the principal axis. This is the height of the image. Had it been like this. Now just imagine if this point is shifted a little bit up, right? Like the following. Suppose if these two rays are meeting over here, in that case a very small image will be formed, but these two rays which are meeting at this point, now this point is slightly moving towards the principal axis and finally it is on the principal axis, which means the image is very, very small dot size, which we call it as highly diminished. So just remember, when the object is at infinity or the image is at infinity, you need to use the word highly, right? So the image over here is highly diminished. Now, we are going to take the same object, that means the object at infinity, but this time the rays are not parallel to the principal axis, they are parallel to themselves. Still the object is at infinity. Now in this case, we may want to use one of the ray diagrams, one of the rules, like if the ray passes through f, instead of going like this, since this is a converging lens, this will become parallel to the principal axis. So both the refracted rays are meeting over here. So that means this will be the image formed because it is real and inverted. As you can see, right, that these two rays will be coming from head. So head will be comparatively down. Now see, this image is not formed at the focus. This is outside the focus. So we may want to call this as a focal plane, right? So this is a three-dimensional, say for example, paper, which I am keeping in such a way that it passes through the focus. So the image is not on the focus. Focus is a point on the principal axis. So the entire image is not on the focus. It is going outside the focus, right? So this is known as the focal plane. So the image is formed at the focal plane. So I hope that all 7 cases are very clear. Do post your doubts in the comment section if you have any. Thank you for watching the video, guys.